Welcome to this online presentation on the time value of money and equivalence. Its purpose is to summarize the concepts of time value of money, interest rate, and equivalence of money. First, we will consider the time value of money. For all of us, we inherently understand that money makes money over time. As an illustration, assume you and a business partner invest a relatively large amount of your own money in a joint business venture. Over time, both of you expect a return of money more than you originally invested. This is without regard to any inflation that may occur. Indeed, it is a well-accepted fact that money makes money. The time value of money concept explains the change in the amount of money over time. This is for investments that you may make where you own the money, or for borrowed funds where it is money that you owe. The time value of money is the most fundamental and important concept in engineering economy. How about interest and interest rate? Well, interest is the manifestation of the time value of money. It is the difference in money between the beginning and the end amount. There are two perspectives of interest. First of all, there is interest earned when lending a specific amount that is called the principal. Then there is the interest paid when a specific amount is borrowed, which is also called the principal. Both perspectives use the same formula, but only one of these two perspectives is present in any particular situation. In the case of interest earned, the relation is the amount owned now minus the amount of principal when it was lent or invested. If the money has been borrowed, the formula is the amount owed now minus the amount of principal that was borrowed. The interest rate is commonly expressed as a percentage per time. For example, 12% per year, or in decimal form, it is 0.12 per year. In percentage form, the interest rate is calculated as shown here. The interest accrued over a time period divided by the original principal times 100% to turn it into a percentage. The time unit is usually called the interest period, and it is commonly 1 year. As an example, assume that exactly 1 year ago the First National Bank lent $200,000. This is the loan amount or the principal. It was lent to Wireless Enterprises, which is a startup company that you have developed. If Wireless transfers $216,000 today to the bank to repay the loan, what are the interest paid and the interest rate amounts from the Wireless perspective? First, the interest, it is simply the total amount that's paid, the $216,000, minus the original amount of the loan, and this is the total of interest paid of $16,000. For the interest rate, you divide that $16,000 in interest by the original amount of principal and multiply by 100% to make it a percentage, and you see that the interest rate paid is 8% per year. This example is from the perspective of the interest paid. When interest is earned, the interest rate is called the rate of return, or ROR. When invested funds earn at an interest rate of, say, 8%, the rate of return is 8% per year from the perspective of the person or the corporation making the original investment. Finally, we will discuss economic equivalence. This is the second most important concept in engineering economics. It combines three vital concepts: the time value of money, the timing of cash flows, and the interest rate. These are combined to develop the equivalence of money over time. By definition, economic equivalence is this combination of interest rate, cash flow series, and the concept of time value of money to determine different amounts of money at different points in time that will make them economically equivalent, or in other words, equal in economic value. The interest rate that is used is very important in the concept of equivalence for engineering economics. It must be the same over time for the different amounts of money at different points in time to be equivalent. Here is an illustration. Suppose that your grandparents just offered you a gift of $1,000 today, or $1,100 exactly 1 year from now. Why? Because you made all A's and B's these past 2 semesters. Which offer should you take? Well, if money earns 10% per year, it makes absolutely no economic difference. Why? Because from an economic viewpoint, both amounts are equivalent at 10% per year. Now you should note that your decision to accept the gift now or later is a function of the interest rate from an economic perspective. However, if you do take the $1,000 now and forego the $100 extra a year from now, you have set aside the economics of the 10% gain. However, let's suppose that money is worth only 5% per year rather than 10%. Then the equivalent amount 1 year from now is 1,000 times 1.05, or $1,050. Well, in this case, you should wait for the $1,100. Why? Because that $1,100 next year is equivalent to $1,000 now, but at a higher interest rate, namely 10%. Now for an example. Here is a cash flow diagram showing money last year, now, and next year. The interest rate is 6% per year, as mentioned here. This cash flow diagram shows that $94.34 last year, or 1 year ago, is equivalent to exactly $100 today, and to $106 exactly 1 year in the future. These calculations are shown below the diagram. The amount of interest during the last year at 6% is $94.34 times 0.06, or $5.66, to make the equivalent amount now $100. Similarly, the interest at 6% for the $100 makes the amount equivalent to $106 1 year from now. In a similar fashion, different cash flow series can be economically equivalent to each other. Let's assume that $10,000 is borrowed today at an interest rate of 5% per year. Here we see 3 repayment schedules. They are all equivalent because they have a current value of $10,000 when the time value of money is considered. As you can see, the timing and amount of each repayment amount over the 3 years is different for each schedule. The techniques to determine these amounts are discussed later. Notice that the total amount repaid varies considerably, from $10,500 for Plan 1 to $11,576 for Plan 3. This is because of the manner in which the interest due is determined and the timing of the cash flows. Plan 1 requires payment after only 1 year, with no repayments during the 2nd and 3rd year. Plan 3 allows the borrower to pay nothing for the first 2 years and pay everything at the end of the 3rd year. This Plan 3 is accumulating interest at 5% per year during these first 2 years of non-payment, therefore increasing the outstanding balance that is due in year 3. This is the end of the presentation. We have learned concepts here that will be used numerous times in the future. They are the time value of money, interest, interest rate, and equivalence. Thank you for watching.